All right, greetings everyone. Here is a recorded lesson for Monday the 23rd, April 23rd, and we're looking at geometric sequences and series today, and kind of reminiscent of arithmetic sequences, only now we are not looking for a common additive constant like we did with arithmetic. We're looking for a common ratio, which means that we're going to look at a term, not the first one, and we're going to divide the one before it into that term, which will give us a ratio. Then we'll move to the next one and repeat, the next one and repeat, the next one and repeat. If that ratio ends up being the same all the way through your sequence, then you've got a geometric sequence, which means that's kind of how we're going to test for a geometric sequence. So looking at A, for example, can't start with 3, so we'll go to 12. All right, 12 over 3, that's going to be 4. And then 48 over 12 is also 4. So it's looking promising. And we'll just look at 126 over 48. And actually, that's not going to be 4. This is more like 2.625. So that breaks up the common nature of it, and so we do not have a common ratio, we do not have a geometric sequence, so that is a no. So we'll check the next one, and we'll start out with 1, which is the first one in, not the very first one. So it's 1 over 5, that's going to be 0.2 for purposes of comparison, and then 0.2 over 1 is also 0.2. 0.04 over 0.2 is also 0.2, and this is just telling us the whole thing keeps going, and so the ratios of these fractions are all the same. So this is going to be, yes, it is geometric, and R will be 0.2. All right, so we'll look at C, and we do note that we have alternating signs on this. We might make you think that that's not going to work, but let's try it. So negative 6 divided by 9 is negative 2/3. Let's check the next one. 4 over negative 6 reduces to negative 2/3. Aha! So we'll check this last one. So negative 8 over 3 divided by the one before it, which is 4, and we'll do the math on that one. So negative 8 over 3 times 1/4, reduce, that's a 2. So we do get, again, negative 2/3. So this one would be absolutely yes, and R would be negative 2/3. So that's how you identify whether or not your sequence is geometric. And so once you've established that you have a geometric sequence, or maybe if you're told that you have one, we would need to find or have some way of finding any given term within that sequence. And that's the nth term of a geometric sequence. Recall that we had a couple of formulas for the nth term of an arithmetic sequence. Here we have a formula for geometric sequence that looks like this. And that's actually what we would use for the rule for a geometric sequence once we figure out the pattern. So it's just any term that we want, nth term. It's going to be the product of the first term times the common ratio raised to this n minus 1 power. And we're going to probably generate a variant of that moving forward, like our last example, and it will seem a little different, but let's just deal with that when we get to it. So for example, to write the first 5 terms of the geometric sequence, A1 is 6, and R is negative 1/4. Well, that is your first term, but I will run it through the formula just to verify. So A1 is the first term, which would be 6, times 1/4 raised to the 1 minus 1 power, which is the 0 power. Anything to a 0 power is 1. 1 times 6 is 6. Good. All right, so that verified that. Now the second term will be the first term times R raised, that's 1/4. Let's make that 1/4. raised to the 2 minus 1 power. So make that negative. We'll get it. And so 6 times negative 1/4 is negative 6 over 4, which is negative 3 over 2. So that's your second term. Your third term would be your first term times negative 1/4, that's r, to the 3 minus 1 power. Well, this would be squaring, and that's going to have the alternation continue because we went from positive to negative. This will be back to positive for an even exponent. So that will be 6 times 1 squared is 1, and 4 squared is 16. So we can do a little reducing here. That'll reduce with that. That'll be 3, and that'll be 8. So the outcome for that is 3 over 8. The fourth term is your first term times r to the 4 minus 1 power, which would be 3. That's back to an odd exponent, so this will go back to a negative outcome. So 6, and that would be negative 1 to the third is negative 1, and 4 to the third is 64. And again, we can do some reducing here. So 3 and 32. That's negative 3 over 32. And finally, your fifth term is your first term, and that's times r raised to the 5 minus 1 power, which is an even exponent now, back to a positive result. So 6, and that would be negative 1 to the fourth is 1, and 4 to the fourth, I believe, is 256. And again, a little reducing here. So 3 and 128. So that'll be 3 over 128. All right, so here they all are listed. 6, negative 3 over 2, 3 over 8, negative 3 over 32, and 3 over 128. So there you go. That's how we go about figuring out terms in a geometric sequence. So let's pause while I get this second sheet up and running. So stand by. All right, we're back recording, and here is page 2. The first example is going to kind of bring back this idea of recursive. We're supposed to find the first 5 terms of the geometric sequence, determine the common ratio, and write the nth term of the sequence as a function of n. In other words, write the rule for it. And so looking at this, here is your first term, and it defines the next term based on that first term. So a to the k plus 1, the one that comes after, is 1/3 the one that comes before. So writing this out, we do have a1 equals 81. Hold on just a second. Let me get this back to the color that I prefer. Okay. All right. And then your second term is going to be 1/3 of your first term. So 1/3 81 is 27. And your third term will be 1/3 of the second term. So 1/3 of 27 is going to be 9. And your fourth term is 1/3 of that. So 1/3 of 9 will be 3. And then your fifth term is going to be 1/3 of the fourth term. 1/3 of 3 is 1. All right, so there are your first 5 terms: 81, 27, 9, 3, and 1. So that's part of our answer. And then we're supposed to write the rule for this. Easy enough, I think. We just need to go ahead and find r, and that would be any of these terms, and it would be divided by the one before it. So we can just do maybe these two right here. That would be 9 over 27, and that should reduce to 1/3. All right, which curiously enough is what was already in the recursive rule. but we can just go ahead and live with just working it out through formula. So here is our writing the nth term of the sequence as a function of n, or kind of writing the rule for it. Any term a sub n is going to be our first term, remember, 81, the one sitting over here in black, times r, which is 1/3 to the n minus 1 power. And that was useful for figuring out any term that we want. Okay, so that's that. Let's go to example 4. It says write the nth term of the sequence as a function of n, and then find the fifth term. All right, the first term is 5, r is 3/2, so that makes it sort of easy to do. A sub n equals your first term, 5, times r, 3/2, to the n minus 1 power. All right, so that's part of what they're looking for. So then they want us to do the fifth term. So that would be, hold on, a little too big. All right, so fifth term is a sub 5, and that equals our first term, 5, to the 3/2. That's r to 3 is 3/2 times n minus 1, which is 5 minus 1. All right, that would be to the 4th power. So let's see, that'll be 5, and then 3 to the 4th power, I believe, is 81. And 2 to the 4th power would be 16. And if you just go ahead and multiply that through, you're going to get 405 over 16. Now 16 is divisible by 2, and if you add up the digits here, that's 9. 9's divisible by 3, so 3 is a factor, but this thing is not going to reduce, so it looks like that's the other part of our answer. Okay. All right. So let's go on to example 5. It says find the 22nd term of the sequence 4, 8, 16. And if you look at that, 8/4 is 2. 4 times, we can just look at it this way. 4 times 2 is 8. And 8 times 2 is 16. So it looks to me as though r is going to be 2. And our first term here is going to be 4. And all right, so I think that's going to enable us to write out the rule for this. So a sub n is going to be 4 times 2 to the n minus 1 power. And now we need to find the 22nd term. That would be a sub 22 equals the first term, 4, and that will be times r, which is 2, to the 22 minus 1 power. And that would require a calculator, because I'm personally not able to go that high with my exponents. So this will be 8,388,608. So there we go. All right. All of this has been, I think, on the easy side. Here it is, example 6 is what I really need to stick a star on, because this is a bit more advanced, and students tend to watch it happen and just not really remember it or practice it, and then can't do it on a test or a quiz, and that's not good. So we're supposed to find the 14th term of the sequence if the 4th term is 125, so let's mark this down symbolically. A sub 4 is 125, and the 10th term is going to be 125 over 64. All right, yeah, we're supposed to find the 14th term, and in doing so, we're kind of missing the first term, and we're kind of missing r as well. So what to do? Well, this is how we will go about doing this. we'll just start out, we'll call this step 1 over here. And watch how this works. It's kind of a variant of the very first formula that we had that set up the rules for generating these things. So we're just going to take the subscript, or the term that's the biggest or the furthest along. It's clearly not the biggest, but it's the furthest one along, and we'll just start out with that. A10, and that's going to equal A4 times R to the 10 minus 4 power. And this will enable us to calculate R. So our 10th term is 125 over 64. That's going to equal 125 times R, and that'll be to the 6th power. And it looks like the only thing that's missing here is R. So why don't we just go ahead and solve for it. So we'll multiply by 1 over 125. And you can kind of see this beginning to fall into place. This will cancel out with this. And we're going to get 1 over 64 equals R to the 6th. And then it's just a matter of taking the 6th root of both sides, which sounds a little scary, but it's like raising this to the 1/6 power, and your calculator can handle that. So R is going to equal 1/2. All right, so that's good stuff. Good stuff. And so now we need to figure out the 14th term. And we're going to make this sort of a step 2, and we're going to do this in a similar fashion that we did in step 1. We're going to take the largest subscript, which between, and we'll just do the ones closest together, A14 and A10. We could do A14 and A4, but that'll generate an exponent that's pretty big. So let's just start out with A14 equals A10 times R to the 14 minus 10 power. See the connection between the two? So your 14th term is going to equal your 10th term. That's going to be 125 over 64 times 1/2, our newly discovered value for R, and that will be to the 14 minus 10 power. All right, so that'll be to the 4th power, and so let's see. So A14 equals 125 over 64, and so 1 to the 4th power is 1, and that's 1 over 16 should be, and it's just the product of these two right here. So your 14th term is going to be 1 times 125 over 64 times 16, which is 1024. And that does not reduce. So there we go. That is your answer. You get it to it in a sort of a roundabout way, but that is the process for doing it. So work problems like this, study problems like this, once you do a couple of them, they're pretty easy, but that's really, as far as I'm concerned, is what's difficult about this particular lesson. So that's what we had for today, and study hard and do well, and we'll see you next time.